In Chapter 11, we're going to be talking about something called electromagnetic radiation. And before we get into that, I'm going to do a little demonstration here. This is a really fun one for kids, so you might, if you have kids at home, you might enjoy letting them watch this as well. We're going to look at some different colors from the electromagnetic spectrum. So let's start out with this first beaker here. Now, by the time I've added both of my chemicals to that beaker, it's going to change a color. Why don't you see if you can guess what color it's going to become? So let's add a little bit of this first chemical here. And now we'll add the second one. See if you can guess what color you think this is going to change to. Ooh, I think it's pretty obvious. That's a lovely red color. One of the colors of the rainbow. Now let's take our second beaker. What color do you think we're going to get here? At this point, when the kids are guessing, they're still all over the map. But you guys, being chemistry students, may be able to figure this out a bit more quickly. We'll add some of our first chemical here again. So let's see what color this second one becomes. Ooh, that's very pretty. That looks like a lovely orange color. Maybe you're beginning to see a pattern here at this point. Can you predict what the third beaker is going to do? I suspect a lot of you are probably figuring this out by now. So let's add our first chemical. And our second one. And you're probably not real surprised it turns a lovely yellow color. At this point, you're probably realizing this looks a lot like the colors of the rainbow. Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. So let's go ahead and see if our prediction is correct. If we are predicting correctly, the next color ought to be green. Well, lo and behold, it's a lovely green color. If we go to our fifth one, we should be to blue. All right. And beautiful, a lovely blue color. And of course, last in the rainbow ought to be violet. So let's take our sixth beaker here. Add our first chemical, and let's see if we get the final color of the rainbow here. And there we go. So the colors of the rainbow: red, orange, yellow, green, blue, and violet. Sometimes they put indigo in there, but indigo is sort of difficult to see. It's essentially just a combination of blue and violet. Now you might be wondering what this seventh beaker is for. We've got the colors of the rainbow, so now we're going to move into a question that might be more of a chemistry student level. In the spectrum, what comes after violet in the spectrum? The answer is ultraviolet. Now, ultraviolet rays, we can't see those. That's why sometimes we don't realize we're getting sunburned or suntan, because ultraviolet radiation is beyond the visible spectrum. So these colors represent the visible spectrum. Those are the colors that our eyes are able to see. Ultraviolet radiation is essentially colorless. It's simply beyond the ability of our eyes to see. But let's go ahead and give it a try here. Let's see what we get if we try to look at ultraviolet light. And not very surprising, if there's ultraviolet light or ultraviolet color in there, we can't see it because it's simply beyond our ability to detect with our eyes. Now, when you mix all of the various colors of the rainbow, what do you get? You learned this back in elementary school, I'm sure. If we combine all the colors, we get white light. That's what basic light is. So the white light coming out of these bulbs is essentially a combination of all those different colors. So let's find out if that's really true. Let's take all of our beakers and we'll put them together in this one flask. So we'll start with our red. And now let's add that lovely orange color. Well, so far it doesn't look white, it just sort of looks red-orange. We'll add some yellow to it. Yeah, well, still looks sort of orange. We'll put some green in there. Yeah, still not colorless. Let's see what the blue does to it. Looking a little bit sort of a violet color from the red and the blue. Let's go ahead and add that violet to it and see what we end up with. Well, we're getting real close. What do you say we just throw in a little bit of ultraviolet light for good measure? And why, lo and behold, we've got white light. Now, for you chemistry students, of course, you're probably wondering what happened here. Well, in Chapter 5, which is coming up in a few weeks, we're going to be talking about acids and bases. And acids and bases will cause certain kinds of chemicals to change color. In each of these first 6 beakers, I had put an indicator. And each of those indicators happens to be colorless in the presence of acid, but they change a lovely different color if you add a base. When I added the chemical from the graduated cylinder, it contained sulfuric acid. So it made each of the indicators in the beakers acidic, and in that case, they're all colorless. In these smaller beakers, I had sodium hydroxide, which is a base, and as soon as we added enough of the base to the flask, it neutralized the acid, the solution became basic, and those lovely colors appeared. Like I often do with demonstrations, I saw this demonstration years ago. My colleague and friend, Mr. Hastings, used to do this demonstration. I really enjoyed it. I added this 7th beaker just for fun. There's really not ultraviolet in there. I simply didn't put an indicator in there. Instead, I added some concentrated sulfuric acid to it so that the solution would remain acidic. When I combined the first 6 together, you could see all their colors, but then we added the so-called ultraviolet flask, which simply had a lot of sulfuric acid in it. The acid changed the solution back to acidic, and all of those 6 different indicators went back to their colorless form. When I do this for young kids, of course, we don't get into the technical part of it. They just think rainbows are fun. And who doesn't?